All right, and we're rolling along. Probability, section 10.5. Find the probability of independent and dependent events. This is typically when you find the probability of doing one thing after another. Picking, two marbles out of a bag, one after another. Picking, what's the probability of picking a king twice? Like, if you pick two cards out of a deck, what's the probability of picking a king the first time and then the second time, and you would multiply. And so whether or not they are independent, imagine, here's a great one, right? So if I say, hey, what's the probability of picking a king twice from a deck of cards, you should say, hey, do I replace the card that I picked? Because imagine if you do pick a king out of a deck of cards and you hold it, say, oh my God, I just picked a king. The next time when you go to pick another king, realize there's only 3 in the deck. There are less cards to pick from, but 3 kings. So it changes. And again, that's whether or not the events are independent or dependent. So here are the vocab words. You're welcome to write them down, but basically that's what I meant. Independent, hey, put the card back, and it has no effect. One probability has no effect on the other. Dependent, they are. So let's get into some, sorry, I apologize. We do multiply, and I think I've been saying that over and over again. When you have the probability of, doing one thing and another, then we multiply. If it's an or, we add. Multiply when you get and, add when you get or. So here, finally, example 1. Every morning, one student in class of 24 students is randomly chosen to take attendance. What is the probability that the same student will be chosen 3 days in a row? So will it, you should be saying this is definitely independent, because it doesn't matter, like the second day, it has no relevance that the day before that student was chosen. Does that make sense? So let events A, B, and C be the student being chosen on the first, second, and third day respectively. The 3 events are independent. So the probability is just basically on the first, if you just wanted to know what the probability is on one day, to get one student out of 24 is 1/24th. But then you're going to do it a second day and a third. And it's, again, you should kind of feel that this is very unlikely. The probability of this happening is very low. It'd be amazing, like, out of 24 students, Jimmy, you're doing what was it again for, take attendance. Jimmy, you're taking attendance. And the second day, I'm picking randomly. Jimmy, you did it again. And the third day, oh my God, Jimmy got picked again. The likelihood is very low. And again, if you add these, you won't feel that lowness. So you multiply the probabilities. This one's a tricky problem, I gotta admit. So here we go. This is a manufacturer found that 2 out of every 500 coffee pots he produces are defective. What is the probability that at least one coffee pot is defective of his first 300 pots made? So the solution here is basically, hey, let's figure out the probability of not making a defective coffee pot. So again, if 2 out of 500 are defective, then the remainder, or 498 out of 500, are not defective. So the probability of a not defective is high. It's 99.6%. And so what you want to do is, if that were to happen, basically you're gonna do that 300 times in a row. Does that make sense? 300 days in a row, you've got a high probability of no defect, no defect, no defect. And so if you want to figure out the probability of making at least one defective pot, take away when you have no defective pots. So again, this is 100% minus the probability of never making a defective one. And that will give you at least one. Again, anytime this at least, we've seen this a bunch, at least it's nice to go from 1 or 100% likelihood, take away what's not included in that. At least one defective pot would mean no defective pots. No defective pots is 498 out of 500, but that has to happen 300 times in a row. So you multiply, you raise to the power of 300. Tough problem. Good tea. Hey, a couple example problems you might want to try. Problem 2 is similar to the hard example we just did. Go ahead and hit pause. Again, read this over. Please try it. When you're ready, hit play. And there are your answers. So for problem 1, you've got 9 competitors. They're lined up in 3 different races. So the first thing you should say is there any dependence on the events, and there isn't. So basically, you've got lanes 1 through 9, and you're wanting to find out the probability if he gets in lanes 1, 2, or 3. So really, that's a probability of 3 over 9, right? The first race, the probability of getting into either lanes 1, 2, or 3 out of 9 possible is 1/3, and that happens 3 times. Or, I don't know, that's a fancy way of just writing 3 over 9, 3 over 9, right? Raised to the power 3. Should get 1 over 1/27th, which is 0.037, actually. And then this is a hard one. A manufacturer found that 6 out of every 450 batteries produced is defective. What is the probability that at least one battery is defective of the first 100 produced? So again, we're going to take one, so at least one defective. Let's subtract away when there are no defective batteries. So what's the probability of no defective batteries? Well, there's 6 that are defective, and the rest are not, which is 444 out of 450. That's the probability of no defective batteries, and that has to occur 100 times, right? Because it's every, the first 100 produced. So every time you produce one, what's the likelihood of defective? And basically, again, nice way to say, hey, let's subtract away where there are no defects. And you should get that answer. So now we're into, this, again, nice formula here, basically saying take the probability of the first event, but the second event, the B, is dependent on what happened on the first event. And so let's get into some of these examples. So here, this is, it's not a great example, I'll have to say. Sorry, that's terrible. I'll take it back. It's a pretty decent one. But basically, here, let me bring this up. So first time, it says find the probability that somebody, in this group has blue eyes. And so you look and you say, well, blue eyes, there are 35 plus 9, or 44 blue-eyed people out of a total of 200. And that's your probability. And then they say, what's the probability that they're blue and male? Which I think is just pretty common sense. You would say, well, what are the total males? Add these numbers up. There are 100 of you, 100 of them. And then how many blue? 35 over 100. So again, not as exciting as this next example. Let's do this. And these last two examples are huge. So really, if you can follow these, this would be great. You randomly select 2 marbles from a bag containing 15 yellow, 10 red, and 12 blue marbles. So again, you should be triggering saying, oh, you're picking 2 marbles, not 1. 1 marble is an easy problem. We were doing those yesterday, right? Or today even. But if we pick 2 marbles, so first off, they say, hey, what is the probability that the first marble is yellow, the second marble is not yellow? And you replace the first marble before selecting the second, independent, right? And then the second B says you do not replace the first model, which would make it dependent. Because you'd be holding a marble, you would have one less marble to pick from. So that probability is affected by your first pick. So here we go. We're independent, right? There are 15 yellow marbles out of a total. You'd add these 3 numbers up and say, oh, there are a total of 37 marbles. And then I got to multiply. I get to put that marble back, and then I want to pick a non-yellow, which is, obviously 37 minus 15 is 22, out of, again, a total of 37. So these events, these probabilities have no, they're independent of each other. And you, again, multiply, and you get a number of 24%. That's pretty good likelihood. But check out the second problem. You get to hold it. So again, you're only interested in when you actually get a yellow, right? So here, you're basically saying, oops, let's get rid of this. Right? No, that wasn't good. You're basically saying, okay, I'm going to pick the first probability, again, has no effect. It should be the same as the last time. There are 15 yellow, and you're picking 37. But check out this 36. Why does this drop? Because you're holding a yellow. You said, oh my God, I got a yellow. There are still 22 because that are all the non-yellows. But this number goes to 36, and that is tricky. Let's do one more. So your teacher that's me. Your teacher passes around a box of 10 red pencils, 8 pink pencils, and 13 green pencils. If you and 2 people in your group are the first to randomly select a pencil, what is the probability that all three of you pick pink, that you select, that's easier, that you select pink pencils? I was going to say pick pink pencils. Select better. So what happens here is that it's dependent, right? So if you pick a pink, the next person has one less pink to pick from and also one less pencil to pick from. So you can see here, look at this formula, right? You've got 8 pink, and add up these three numbers, you should get 31. So you've got 8 out of 31 to pick from. And I got one, I got a pink, yay! And then it's your turn, right? Your partner. There's one less pink to pick from, but there's also one less pencil to pick from. And then the second person, oh my God, we both got pink, high five. And then you go again. The next person has only 6 pink because you and your friend are holding 2, but there's also 2 less pencils to pick from, so it goes down to 29. And this problem is the big one, right? This is really gets the big star. This is where you've got 3 or multiple dependent events where you hold whatever you picked, and you can see how that affects your probability. Hey, 3 examples to pick from, or to try, excuse me. Too many picking. See if you can't do them. It's pretty straightforward. Hit play when you want to see the answers. And there are your answers. So here, this is pretty straightforward. This is probability of females with hazel eyes. There are 41 hazel-eyed females out of a total of 100. And so the second one here, this is where you're picking a yellow. The probability that you're picking a yellow twice. And so the first time you've got 15 out of 37 marbles, and then you put the marble back. So again, you've got another 15 out of 37. So these are independent events. It's kind of a boring problem. The second part is fun though, right? So you pick a marble. Hey, you get a yellow. So you're excited. Now go back and see if you can't get another yellow. Well, check it out. There's only 14 yellows out of a total of 36 yellows to pick from. And so this probability, when you multiply this, you should get 15.8%. And then finally, this one is the same as the example 5. What's the probability that you and your group member all choose red pencils? So the same scenario happens here. There are 10 red pencils out of a total of 31. And you pick first, and you got one. Now there are 9 red pencils left to pick from, and out of a total of 30. And then you go down again to 8 out of a total of 29. And that should multiply up. Hey, great job listening to the video. Can't wait to see you guys in class tomorrow. And we will try to do lots of homework problems in class.